Find the critical points of y equals stuff. All right, the way you find critical points is you take the derivative and then set that equal to 0. So let's take the derivative, y prime. Y prime is going to equal 3, drop it down, x, turn that into a 2, minus, drop the 2 down, make it a 22, x to the regular x, plus 39, and that's it. Now I have to set it equal to 0. So 0 equals, can't factor it out. Can't factor it out. But once I get to this point right here, I could use a good old friend called the quadratic formula. Maybe it does factor out. I mean, it doesn't factor out regularly. You probably can factor it out, like maybe using like 13s and 3s, but I don't know. I'm nervous and I'm not going to risk it. So I'm going to use the good old quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So x equals negative, so here's my a, negative 22 is my b, and 39 is my c. So x equals negative 22 makes that positive 22. See what I did there? Plus or minus the square root of negative 22 squared minus 4 times a, which is 3, times c, which is 39, all over 2 times a, which is going to be 6. Ugh. All right, well, that'll become regular 20. Let's just use Siri. 22 squared minus 4 times 3 times 39. Oh, no way. It's 16. By the way, I said 22 because I knew that would become positive anyway. Oh, how nice is that? All over 6. So when you split this up into 2, x is going to equal 22 plus or minus 4. So we'll do plus 4 over 6. And x equals 22 minus 4 over 6. 22 plus 4 is 26. 26 over 6 simplifies to 13 over 3. 22 minus 4 is 18. 18 over 6 is 3. So these are my two guys. My critical points are going to be 13 over 3 and 3. Now for many problems, critical points might require you to find the y value, but for these, we're only going to find the x value. If you want to find the y value, you would just plug 13 over 3 into the original equation, plug 3 into the original equation. But this leads to a concept known as increase and decrease, looking for intervals of increase and decrease. And usually for problems like that, we don't really necessarily care about the y value. All right, so I'm going to leave it like that.